All right, guys, and the last question I'm going to do here before I'm going to have to sign off on this first live stream is it a whole or an asymptote? All right, so how do you know? Or another way to do it is, how do you know, is it removable or non-removable? Okay, so I was teaching this actually today, and I kind of ran into an issue which I found, the students. I think the main thing is understanding where the domain is, and at least understanding the discontinuities. Because when we look at a graph, it's easy to understand where the discontinuities are. That's where the graph, obviously the graph either breaks apart or we can see that the graph is undefined. So I think the main important thing is understanding where there are discontinuities in the domain. So this is a rational function. When identifying the domain of a rational function, we're going to set the denominator equal to 0. So I'm just going to find the domain real quick. Now, this is not part of the question, but I found this to be easy for people to understand this type of question, is by understanding the domain first. It's not necessary, but it's helpful. Now, let's go ahead and factor this. So to solve for this, I'm going to want to factor it. So I'm going to do x plus 3, and x minus 1. Okay, now I can use the zero product property, set each factor equal to 0. And then x is equal to -3 and x is equal to +1. Okay, so these are the values that make my denominator equal to 0. These are the values that are not in the domain, right? These are not in the domain. These are the values that make my denominator equal to 0, right? Plug in -3, plug in 1. They make the denominator equal to 0. They're not in the domain. So what type of discontinuity are they? Are they a whole or are they an asymptote? Are they removable or are they not removable without even looking at the graph? So the way to do that, okay, but you got to understand these are your discontinuities. So the way to do that is to simplify f of x. So we're going to simplify f of x by factoring the numerator as well as factoring the denominator. By factoring the numerator, I'm looking for what two numbers multiply to give you 3, add to give you -4. That's going to be an x minus 1 and a x minus 3. As far as the denominator, we already factored that out when we were finding the domain. That's x plus 3, and that's x minus 1. All right, so now what we notice is if we were to simplify this, right, simplifying rational expressions, we recognize that since we have this product of them and we have expressions that are exactly the same, we can divide them out. So we can simplify this to x minus 3 divided by x plus 3. And I didn't really mean for it to be pluses, use 3's both case. Crap. But either way, that's what we have. Now, that's a simplified expression. We know there's a discontinuity at 1. 1 makes the denominator equal to 0. It doesn't make the denominator equal to 0 of the simplified version, so we have to understand that 1 got removed, or x equals 1 is still not in the domain, right? Because it produces a whole. If you were to graph this equation, there would be a whole at x equals 1. On the equation, it gets simplified, it gets removed, it gets canceled out, it gets divided out when it's simplified. But when it's non-simplified, it's still there. So even though it gets simplified and removed out, or it can be removed out, doesn't mean that it's like all of a sudden not part of the domain anymore. It's still not part of the domain. It's just it can be removed algebraically. Whereas the non-removable discontinuity is the discontinuity that cannot, that's still in the denominator. So this is your non-removable discontinuity. You can't divide that out. You can't simplify that out. That's there. That's stuck, right? X plus 3 is your non-removable discontinuity. But again, we're not really talking about x plus 3. We're talking about, well, what happened when we took x plus 3 and set it equal to 0? That gave us the discontinuity of x equals -3. So negative x equals -3, not that -3, but when this x plus 3 is set equal to 0, gives you the value of where the vertical asymptote is, or the non-removable discontinuity. So hopefully